All right, folks, here we go. We are still working on systems of equations. We're going to learn a different method to solve a system of equations today. Now, is it easier? Good question. The answer is it depends on the situation you're given. We learned two ways yesterday. We learned substitution method and we also learned calculator method. And in some cases, to me, it's easier just to substitute. If it's set up nicely to where you can just stick one equation into the other one without much work, then I would substitute. If they're both solved for y, I would use the calculator. If they're going to be set up like this, I would use the method we're going to learn today, which is called the addition method, and sometimes it's referred to as the elimination method. Now, the first time you're going to see it, you're going to say, why didn't you show us this in the beginning? Because it's going to seem so easy. But let me just tell you, these are rigged for this to be the best way. Okay? You can use addition method on any system you ever see. You can solve it in the calculator on any system you ever see. You can do the substitution method on any system you ever see. You just have to look at the situation and decide what's the best way. And I'm just going to tell you right now, these are going to be rigged to where you're going to really like the elimination method, at least for the first few. 5x minus 2y equals 30. X plus 2y equals 6. Why is this a system of equations, first of all? Because there's more than one equation. And we're looking for what? The solution, which means what? Where they intersect. The one point that they share in common. Yesterday we learned how to do it with calculator. We also learned how to do it by substitution. We're going to learn another method today, and I want you to look carefully at the y's. Do you notice anything about the two y values? They're exact opposites of each other, and that's what makes the elimination method so nice. They cancel each other out. What we're going to do is add these two equations together, and those y values are going to cancel each other right out. And that way we can find x in a very, very simple little step here. Add those equations together. What's 5x plus x? 6x. What happens to the y's? They are gone. They cancel each other out. What do I get over here? So 6x equals 36. What does x equal? 6. Now, see how easy that was? Am I done though? No, because we're looking for a point where they intersect. The methods we're learning use substitution at least a little bit. I've got to substitute a 6 back into one of the problems, right, Saul? Saul is eating paper right now. Please stop. All right, Saul, after you finish your little snack there, which equation should we put 6 back into for x? You're not sure. Guess what? It doesn't matter which one you put it back into. Whichever one looks easier. To me, the bottom equation looks easier. Let me erase my title so I can do some work here. I now know that x is 6. So I'm going to put a 6 into the bottom equation. So instead of x, I'm going to put a 6 plus 2y equals 6. I've got to subtract 6 from both sides. What does 2y equal? 0. Subtract 6 from both sides, you get 0. For some reason, kids are very bothered by the number 0. It's just a number. What's the y value here? Now, divide by 2, so what does y equal? 0. So where do these two lines intersect? At 6, 0. I also could have put the 6 back into the top equation. Once I get one of my values, I put it back into either of the equations I started with. Let me try to put the 6 back into the top. So this, instead of 5 times x, it's going to be 5 times 6. That would be 30 minus 2y equals 30. Subtract 30 from both sides. You get negative 2y equals 0. Well, what's 0 divided by negative 2? Still 0. I still got the same value. Now, again, that problem was rigged for addition. But if I were to see that question on a test, I would think, hey, the easiest way to solve that one is addition. And that's what I would do. Look at number 2. 5x minus 4y equals 1. 7x plus 4y equals 11. Do you think this is going to be one that could nicely and easily be solved by the addition method? Why? Because the y values have opposite coefficients. The fact that they're opposite is very important. They have to be opposite. And they have to be the same digit with opposite signs. That way, when I add up these two equations, the y's cancel out. They're eliminated. We have to make an equation with just one letter so that we can find one part of the answer and then the other. All right, so add them up. What do we get? 12x equals 12. What does x equal? 1. Am I done? No. I have to go back to one of my equations now and do what? Plug in a 1 wherever I see an x. So let's go to the top equation. 5x minus 4y equals 1. I'm going to put a 1 in for x. 5 times 1 is 5. 5 minus 4y equals 1. Negative 4y equals negative 4 once I subtract 5 from both sides. So what does y equal? 1. Negative 4 divided by negative 4 is 1. So what's the answer here? 1, 1. Let me show you something else. Let's say this was a multiple choice test and you completely forgot how to solve a system of equations. Your mind went blank, but you knew you had to find a point that they both shared. And you have a whole list of answer choices. What could I do? Plug them in. You're looking for the one that works on both. 1, 1 better work on both, and let's see if it does. Let's put a 1 here. What's 5 times 1? 5 times 1 is 5. What's 4 times 1? 4. Does 5 minus 4 equal 1? So does 1, 1 work on this one? Yes. Let's see if it works on this one. Put a 1 in here and I get 7. Put a 1 in here and I get 4. What does 7 plus 4 equal? 11. So even if I didn't know how to solve it, I could guess and check the answers. 1, 1 is the only point that those two lines have in common. All right, let's look at another one. Number 3. Now we're getting to ones that take a little bit more work. All right, now, unfortunately, folks, adding these two equations together will not accomplish anything for us. It'll just make a third random equation. Why won't it help us to add these together? Because nothing's going to cancel. It doesn't always have to be the y's, by the way. On the last two examples, the y's happened to be the variable that canceled out. That doesn't always happen. Sometimes it's the x's that cancel. Does anybody have any? Oh, that's not going to help you. You got to make one of the letters cancel. You have to make one of the letters cancel. Does anybody have any idea what we could do? Oh my gosh, listen to that. Brilliant. Did you hear what he said? Multiply the top equation by 3. Is that legal? Are we allowed to multiply an equation by something? Absolutely we are. Why would we choose to multiply the top equation by 3? Why would we want to multiply by 3? So that the y coefficients would be exact opposites and then they could cancel. So yes, that's a great answer. Good job, Ryan. I would definitely multiply the top equation by 3. Now that's completely legal if you do it to the whole equation. And that equation is now going to look different, but it's going to be the same equation. Eric, tell me what the new equation looks like. Thank you, Eric. 12x minus 3y equals 21. Sure enough, now my y's will cancel or be eliminated when I add these together. And I'm getting what? 17x equals 34. What does x equal? 2. Please don't say anything, but now go back and put 2 back into any one of the equations, either the 2 pink original ones or even the new blue one that we just made. Put a 2 back in for x somewhere on any of those three equations up there. Whichever one you think looks the easiest. And then show me your answer with your hands, what you get for y. Good, good, good. Alright, seriously, what did y'all get for y? 1. I'm going to put 2 back into this original pink equation right here. I'm going to put 2 in for x. Now I would have 8 minus y equals 7. Subtract 8 from both sides. Negative y equals negative 1. And y would equal 1. So how would I write the answer? 2, comma 1. Because x was 2, y was 1. Right? Are we good with that? Would you still get a 1 if you put the 2 into a different equation? Is that what you're asking me? Yeah, I put it into this one. Let's put it into this one. If I put a 2 in for x, I'm going to get 10 plus 3y equals 13. Subtract 10, I get 3y equals 3. And I still get 1 for y. What about it? That is where I put the 2. Okay, now look at this one. Number 4. 5x minus 2y equals 8. 2x plus 7y. Actually, you know what? Let me switch this up a little bit. Negative 2x minus 7y equals negative 11. Okay, we have a situation here, folks. It's kind of like, yeah, you have to find a common multiple of either the x's or the y's. If we want to do the elimination method, we have to force either the x's to have opposite coefficients or force the y's to have opposite coefficients. On all the examples we did so far, the y's canceled out. In this problem, it's really going to be easier to make the x's cancel out. Can you understand why? Because the x's have opposite signs at least. Do you see how the y's are both negative? So if I want to force the y's to cancel out, I'm going to have to multiply by something negative. Because I can't have two negatives. I've got to have a negative and a positive. So really what I'm going to do, even though I could make the y's cancel, I'm going to focus on the x's because at least they already have opposite signs. Now, this is one that I would say you have to double rig. Last example, we just had to multiply one equation by something. And then it made the y's cancel. This time we're going to have to multiply both equations. And Waja, you're on the right track. What should I multiply by? Multiply the top one by 2. Yes. Do you see why he's going to do that? And that's not the only thing we could do. If I multiply by 2 on top, what do my x's become? 10x, right? If I multiply by 5 on bottom, what do my x's become? Negative 10x. And won't that make them cancel? So that's a very good choice. That's exactly what I would do. So who can tell me the new top equation? Eric, how about you again? 10x minus 4y equals 16. Nick, tell me the new bottom equation. Absolutely. And now, the way that we have double rigged this, if we add them together, the x's will be eliminated. And we'll have what? Negative 39 y equals negative 39. Positive 16 and negative 55. Use your calculator. Adds up to negative 39. So what does y equal? It's 1. Positive 1, isn't it? So this time we found the y value first. No big deal. We still have to find the x. Pick an equation. It could be one of the blue ones. It could be the red ones. It doesn't matter. Pick an equation. Put a 1 in for y somewhere. Which one do y'all want to use? Okay, then do that. Nick votes for the second blue one before we changed it. No. If you do that, then you're yeah. Well, let me. I just wrote that so you could see what we were doing. The original equations just look like this. And show me with your hands what you get. Okay, I'm going to put it into the top equation. I'm going to put a 1 in for y. So now this becomes 5x minus 2 times 1, which is just 2, equals 8. Add 2 to both sides, 5x equals 10, and 10 divided by 5 is 2. So what's the answer to this problem? 2, 1. This time I found the y value first, so just make sure you put them in the right order. And it doesn't matter which one you find first. Okay, that was number 4, right? Look at number 5. 2x plus 2y equals 4. 3x minus 3y equals 18. You could, if it would help. The question was, could you divide by something? And yes, you could. Sometimes, though, dividing makes fractions. Usually, the easiest thing to do is multiply. But yeah, sometimes that might... Because actually, if you divided the top equation by 2 and the bottom equation by 3, wow. That would work, Waja, actually. Or, let's practice. Now, which ones would I force to cancel here? I mean, you could do either. I could make the x's cancel, but I'd have to multiply by something negative if I chose to make the x's cancel. At least the y's already have what? Opposite signs. All right, I'm going to let you do this one completely on your own, so get busy. Okay, and I want you to check answers with somebody around you. Personally, what I would have done was multiplied the top equation by 3 and the bottom by 2. That's personally what I would have chosen. 6x plus 6y equals 12. 6x minus 6y equals 36. The y's cancel right out. 12x equals, what, 48, and I'm getting 4 for x. Is that what y'all got? What do we get for y then? 2 or negative 2? Negative 2? All right, let me just double check you. I'm going to put it into the top equation. I'm going to put a 4 in here. That gives me 8 plus 2y equals 4. 2y equals negative 4. Y equals negative 2. Is that the only way to solve this system of equations? Absolutely not. We could have put them in slope-intercept form and stuck them in the calculator and did calculate intersection. If we had the answer choices, we could have checked all the answer choices by putting in 4, -2 and making sure it works. Is this way easy? Sometimes yes, this way is the easiest. This is usually my favorite way. Unless they're already in slope-intercept form. This is usually my favorite way. Now, look at this mess though. 5x equals -3 plus 7y. 19 minus y equals 3x. You may choose, when you see one like this, on your homework tonight, the first few are rigged to where you really need to practice addition. And I really want you to practice the elimination addition method. But when you get one like this, if you don't want to do it the addition way, if you want to put them in slope-intercept form and show me that work, and put them in the calculator, that's fine. You can also do the addition way too, though. The only thing you have to make sure of, guys, is everything, you've got to have stuff lined up. Your x's have to be underneath each other. It doesn't necessarily have to be in standard form, but your x's, your equal sign, your y's, they've got to be lined up underneath each other somehow, some way. Usually kids just to be consistent, they choose to put it into standard form. Then they can do the addition method if they really like the addition method. I'm going to let you choose. You do have to do some rearranging for either method. So you decide which way's easiest or best or makes most sense to you for this one. And then you solve it. Because sometimes you're just going to have to make a choice. Will you ever be tested on this? Yes, absolutely. We're having a quiz Friday, but I don't know if systems will be on it or there won't be that many of them. What I did here is I noticed that the y's could probably cancel out pretty easily if one of the equations got multiplied by 7. So I just rearranged things to where that happened. Some kids chose to put them to just solve for y and solve it in the calculator. How many of you guys did addition? Just one person? 2 people? Most of y'all chose calculator? That's fine too. If I were going to do addition, the easiest way to do addition, if it's all messed up like this, is probably put it in standard form. So with the top equation, I went -7y plus 5x equals -3. See what I did there? And then the bottom equation, I moved the y over. So I would have 19, the 3x, and then this would be a positive y. Do you see what I did there? I just moved this y over here and got y plus 3x equals 19. And then it's not that bad to multiply the bottom equation by 7 and then do the elimination method. It's also not that hard to put these into slope-intercept form and get the calculator to tell you the answer. What did y'all get? 5-4 was the answer. So sometimes you just got to pick the method you like the most and just go with it. Did anybody not get 5-4? Because no matter which way we do it, we should always get the same answer. It is 5-4. Okay, I feel like you guys got it. I do want you to practice the addition method on at least the ones that are set up nicely and rigged for you. or just need a little bit of rigging. But when you get to some that look like the one we just did, if you prefer the calculator way, that's fine with me too. All right, your homework is page 346, 5 through 18. And I do want you to get started right now. So if you have questions, I can help.